Just asked to kind of review the use of augmented matrices to solve a system of equations, of linear equations. I have already taken the system and just wrote the matrix down that is represented by it. So let's see. Let's make one of these ones a 0, okay, by subtracting one of the rows. Okay, so we could do something like row 2 minus row 1. Okay, so I'm taking this row and I'm going to subtract this row. Now you subtract just in the columns. Now notice that row should have been row 3. I'm sorry, row 3. Row 1 is not going to change, so I'm going to just leave it the way it is. 3, 1, negative 3, 5. Now row 2 is what's changing, so I'm taking row 2 minus row 3. So I'll go 1 minus 1 is what? 0. Negative 2 minus a 1 is what? So negative 2 minus 1, negative 3. Sorry, I didn't hear you. 4 minus 1, 3. 10 minus 13, negative 3. And then this didn't change at all. 1, 1, 1, 13. Everybody okay with that? Now let's see. We want to try to make this guy a 1. So how can we make... So what I want to do is I want to try to make this a 1. How can I make that a 1? Now, I could divide it by 3, but then that's going to give me some fractions. So do you have any other ideas? We could just switch row 1 and row 3 if we want to. Let's just do that. So let's just switch row 1. Now the notation that you'll see in your book is you're just switching out row 1 and row 3. I'm just going to rewrite it down here. So this guy is now going to go up top. 1, 1, 1, 13. This guy's going to stay where it is. 0, negative 3, 3, negative 3. And this guy's going to come downstairs. 3, 1, negative 3, and 5. So all I did from here to here is switch my top row and my bottom row. Who's got the roll? Okay. So if you just came in, I did send a roll around today, and it's over there somewhere. I'll try to collect it in about 5 minutes. Well, I still need to make this guy a 0, right? How can I make this a 0? Now, if I divide by 3, then I have 3 divided by 3 is 1, so that's not going to work. So I've got to subtract something. Anytime you're trying to get a 0 in one spot, you want to subtract. So what is it I want to subtract? Well, I've got, this is row 3. I need to subtract 3. So in this column, though, all I've got is a 1. So I've got to do what to row 1? Times it by a 3 and subtract it, or times it by a negative 3 and add it. That's the same thing. So the way I like to do it is we'll say row 3, and then I'm going to subtract 3 copies or 3 multiples of row 1. I don't know why I did that. That's from my geometry days to this morning. I was doing some geometry stuff. Okay, so again, row 2 is not changing. I'm going to leave it there. 0, negative 3, 3, negative 3. Row 1 is not going to change. But now I'm going to take row 3, and I'm going to subtract 3 times whatever's in this column for row 1. So 3 minus 3 times 1 is 0. Then I have 1 minus 3 times 1 is, so I'm going this one this element, row 1, minus 3 multiples of this one. Well, what's 3 times 1? 3. So I have 1 minus 3 is negative 2. A negative 3 minus 3 is negative 6. And then a 5 minus, now if you want to do a little, you could write it like this. 5 minus 3 times 13. That's in this column. So what is 3 times 13? 39. 5 minus 39 is a negative 34. Everybody okay? So there's something nice about row 2 here. So remember, when we want to solve these augmented matrices, what's our goal? We want something of the form 1, 0, 0, 0, 1, 0, 0, 0, 1, and then just some whatever numbers are here, right? Whatever they end up being. If we can get to something that looks like this, that is 1s along the main diagonal and 0s everywhere else, then we've solved the system. So I want to make this guy a 1. Well, this is kind of nice. What's an easy way I can make row 2 have a 1 in this spot, in this element? Divide by negative 3. So I have row 2 divided by negative 3. And row 1 doesn't change. 1, 1, 1, 13. Now, 0 divided by negative 3 is still 0, so that's good. We didn't change anything there. Negative 3 divided by negative 3 is 1. 3 divided by negative 3 is negative 1. And then a negative 3 divided by negative 3 is again a 1. Now, this row didn't change either. Everybody okay? No, you don't have to. That was one of there's 3 operations we can do. So the first one was we can switch 2 rows. That was this one. The other one is you can add or subtract multiples. That's what these 2 were. And the third one is you can just divide or multiply any row by any number.
Okay, that's what I was looking at.
Okay. You guys want me to finish this problem? She had asked about it, and now she says she sees it. You want me to? Okay, what's an easy thing I can do to row 3? Same rule, but do what? So row 3 is this one. Yeah, divide by negative 2. Or just a negative. But if I notice that all of these are even, so I can divide by negative 2. So I'm going to have row 3 divided by a negative 2. And what does that give me? I still have 1, 1, 1, 13. 0, 1, negative 1, 1, 0. This negative 2 divided by negative 2 is a 1. Negative 6 divided by negative 2 is a 3. And then negative 34 divided by negative 2 is 17. I promise you there will be a 1 or 2 of these problems on your next test. Okay, so if you haven't tried them yet, you definitely want to. Okay, well, what's the next thing I want to do? So remember, we sort of work on the first column to get our pattern 1, 0, 0. I've simplified a couple more rows. Now we're working on the second column, and I want to get a pattern of what? 0, 1, 0. So I need to do something to this row to make this 1 go away. Any ideas? What did I say? I said earlier, anytime you need to get a 0 in a specific spot, you're going to have to do what? Add or subtract, right? You can't do any division to get 0. So I'm going to have to subtract. I can use any one of these rows to subtract. It doesn't matter which one. Sometimes you might want to pick the ones that are easier. I'm going to pick row 2. So the operation I want to do is I want to say row 1 minus row 2. Now I picked row 2 because the numbers are a little easier with just these ones. So row 2 and row 3 are not changing, so I'm going to keep those. So now row 1 minus row 2. 1 minus 0 is just 1. 1 subtract nothing is 1. 1 minus 1 is 0. That's what we wanted right there. 1 minus a negative 1. Positive 2. 13 minus 1 is 12. All right, what about, still need to make this guy a 0. What do you think I want to do? Subtract what? Yeah, so I'm going to take row 3 and subtract row 2. In this case, row 1 and row 2 are not changing. 1, 0, 2. Just a matter of being careful with your notation, taking your time. Row 2 is not changing as well. 1, negative 1, 1. Row 3 minus row 2. So 0 minus 0. 0. That's good. This might have been another thing that you were running into here. If I had, for some reason, tried to subtract row 1, I would have had 0 minus 1. Now, what would have that have done? Yeah, that would have made this 0 into a negative 1. That's something you want to look out for. You don't want that. Once you've got your first column the way that you want to keep it that way. So that might have been something you were running into. So sometimes you have to ask yourself, which one of these rows do I want to subtract? But I'm doing row 3 minus row 2. 0 minus 0 is 0. 1 minus 1 is 0. That's good. 3 minus a negative 1. 4. 17 minus 1 is 16. We're almost done. I can see it falling into place. What's something easy I can do to row 3? Divide by 4. Row 3 divided by 4. This gives me the matrix 1, 0, 2, 12, 0, 1, negative 1, 1, 0, 0. 4 divided by 4 is 1. 16 divided by 4 is 4. Okay. So what's the last two steps that I need to do? Remember, look at your form. You always want something like this. Notice I've got 1s along my main diagonal already. I've got 0s in this lower triangle. I've got a 0 here. What else do I need to do? I need to make this a 0, and then make this a 0. Everyone see that from the form? So let's do the second one first. What am I going to do to make that a 0? So this is a negative 1. If I want to make it a 0, then I need to add 1, right? So I can just say row 2 plus row 3. Now, if you would allow me to do this, I'm also going to take the 2 steps in 1 here. The other thing I want to do is I want to make this 2 turn into a 0. So to do that, I'm going to take row 1, and then I'm going to subtract 2 copies or 2 multiples of row 3. So I'm going to do 2 different rows in the same step. Okay. So let's do the first one here. Row 1 minus 2 copies of row 3. Row 1 is 1 minus 3 times 0 is 0. That's still a 1. That's good. 0 minus 0 is 0. And then 2 minus 2, because it's 2 times 1, is also 0. And then 12 minus 8 is 4. Now row 3 is not changing. I'm just going to write it down. And then finally I want to take row 2 and add it to row 3. So 0 plus 0 is 0. 1 plus 0 is 1. Negative 1 plus 1 is 0. And then 1 plus 4 is 5. And what does this tell us our answer to the solution, or the solution to the system of equations is? So this tells us x is equal to 4, y is equal to 5, and z is equal to 4. And if you want to put that in a point, if you were to switch columns, then that would change the answer. Don't switch columns, just rows. Yeah. No, but my suggestion is at least the first few times write it down so you train your mind to think about it that way. Once you get enough practice, it's not necessary. And I'm not gonna necessarily grade it if you don't. I mean, what I mean is, if you get the right answer and you don't have these, then that's fine. So I'll be able to tell what operations you were doing. But it might help you with partial credit. So that if you wrote down the operation, but maybe you just had a sign error in your arithmetic, maybe that can help with partial credit. Again, it is a good way to keep your work organized and to train yourself to do the operations. Any other questions over anything we've done so far? Okay, we are going to go through about 4 sections today, but I've broken it down to just the necessities.